Hello, good morning. Welcome back. Last class we did hybrid inheritance and then I did the explanation of the practical program and you were supposed to write it, which was the homework. Hopefully you have done it, and if possible you have a system, you can download TC, which is a very small and free available software, and it would be better if you can execute it and see it, so that it will help you when the college reopens and when you go to your labs. Today's class will be discussing about virtual base classes and the constructors and destructors in inheritance. These two topics would complete our inheritance chapter. So, before starting virtual base classes, like I'll give you a scenario and we'll go through that. Based on that, we'll be able to understand the definition better. For example, I have a class A. Okay. In that public section, I have void sum. This completes my class. Then we'll say class B public A. That is why, like here, what am I doing? I am going to derive a class B from A. Okay. So, then I will also have class C public A. What happens in both the cases is, since I am deriving a class B from A, this sum B would get a copy of sum from A. Yes, because it is in the public section and I can inherit it. So, it will be void sum in B, correct? And then I am deriving a class C from again A. So, this sum C also would get a copy of that. So, we are clear here. I am having a class A. In that I have a function called void sum. That is, the function sum is not going to return any values and I am not going to pass any arguments to it. And it is declared in the public section of the class A. Then I am deriving a class B from A. So, the derivation is also public and I am calling, so when I do that, apart from B's members, this void sum would be inherited, like B would inherit that, and void sum, B would have a copy of void sum. Same way, I will derive a class C, again public A. So, C will also get a copy of void sum along with its own properties. Now, B also has void sum and C also has void sum. Then I say that class D public B, comma public C. So, what am I doing here? I am having multiple inheritance. So, I will derive a class D from B as well as C. So, it will have one copy of void sum from B, yes, and one copy of void sum from C. So, D will have two copies of void sum. So, void sum 2 of void sum 1 from B and 1 from C. So, D will get two copies of void sum, one from B and one from C, because I derived a class B from A and void sum is there in B. I derived a class C from A, so void sum is in C also. Then I derive a class D from multiple inheritance from B as well as C. So, it will get the copy of void sum from B and also a copy of void sum from C. the declaration or the prototype of the function is the same. There is no difference. That is, the function is not going to return any value and you are not going to pass any arguments to it. Getting it? So now in void main, I will say dobj, then dobj dot sum. So tell me which one will this execute, because I have 2 copies of that. Then which one will it execute? It gives rise to an ambiguity. Ambiguity is nothing but confusion, because it will not know which one to execute, because they are the 2 copies of the same function which D inherits, one from B and one from C. So it will give you error because it will not know what to do, right? Yeah. So understanding this, then that is why we have virtual base classes. To overcome this ambiguity, we have virtual base classes. Now hopefully you have understood that is the same copy of the function, get the derived class getting the same copy of the function multiple times through the different classes. Then when you call that, it will not know, there is an ambiguity or a confusion which function to execute, because there are multiple copies of the same. That is when we use virtual base classes. So if you have understood this, then we will go back to the definition or the statement so that we'll understand it better. So when 2 or more objects are derived from a common base class, we can prevent multiple copies of the base class being present in the derived class by declaring the base classes as virtual when it is being inherited. So that is why we need virtual base class. So when we declare the base class as virtual, it will make sure that only one copy of that gets inherited to the derived class, so that it will not give rise to any ambiguity. So now we'll go through this. You will understand. See, for example, I have class A and I derive class B from A and class C also from A. So class D. So class D will get copy of A from B and will get copy of A from C, because this will get copy of A, this also will get copy of A. So C is okay, B is okay, B and C are same. B will get a copy of A and C also will get a copy of A, and along with that it can have its own properties. But then copy of A, that is the protected and the public copies, will definitely be there. It will elements or will be there. Then when I derive a class from B and C through class D from multiple inheritance or through multiple inheritance, D will get a copy of A from B and D also will get a copy of A from C. So it will raise to an ambiguity when you call that function, because it has multiple copies of the same. So it will not know which one should get executed. For that reason, we eliminate this problem through virtual base classes, so that when you declare base classes as virtual, it will make sure that only one copy of that would be in the derived class. How do I do that? This is the syntax of that. Class A, fine, I have a class A, I will have it. Then I am deriving a class B from A. So how do I do that? Class B, that is, class is the keyword, B is the derived class name, colon, visibility mode. Before printing the visibility mode, I will write virtual, or you can write this way also, public virtual A or virtual public A, does not make any difference. So when I say virtual here, it will make sure that only one copy of A gets passed to B. not multiple. So this is how we create a virtual base class. And why do we need that also we have established. So because of this, only one copy of that would be passed to C, and when you call it, there will be no ambiguity because there are no multiple classes of the same. Multiple functions of the same, right? Please go through this and hope this is a 5-mark question. Please make a note, and when you're answering it, you should be very explicitly clear about the ambiguity, and then how do you overcome it and what is the general syntax of this. So this is about virtual base classes. What are they and why do we need it, and if we don't write, what are the errors which may arise in the program. Please have a look. The next is constructors and destructors in derived classes. So we'll write a program. I will write an output for that. Then we'll discuss the order of execution. Fine. Write a program which highlights the concept of constructors and destructors, the order in which they are executed in detail. What is the order of execution in detail? Fine. So let me start writing my program. So if I say hash include iostream.h conio.h. So let's say class base. Okay. So constructors and destructors both has to be placed in the public section of the class. Here I am not writing any body or anything, since I am only going to illustrate how it gets executed. Let me write only constructors and destructors. Fine. Public. So BAC base. This is the constructor, because constructors are declared in the public section of the class. They don't have a written type, and then they have the same name as the class name, and since it does not have any arguments here, it is a default constructor. So whenever an object is created, this automatically gets executed. Fine. And then so I do have this. I will close my class here. Fine. So this is the destructor, that is tilde with the same name as the class name, and destructor cannot be overloaded and it doesn't take any arguments. That is the thing, right? If it doesn't take any arguments, it cannot be overloaded. Constructors can be overloaded, but since I am not passing any arguments to it, it means it is the default constructor. So I have a class called base. Base is just a concept, it is not a keyword, so I can name it as a class name. Base, and since both the constructors and the destructors have to be declared in the public section, I am having public base. This is the constructor. Destructor. So this is the destructor, this is the constructor. Fine. Let me now write the constructors and the destructors. So how do I write that? It does not have a written type, name of the class to which it belongs to, scope resolution operator, name of the constructor function. So I'll say cout endl in base class constructor. So this will end my constructor. I am not putting a semicolon here because constructor again is a function, and functions are not terminated with semicolon. Only the class or the structure gets terminated with a semicolon. Now let me write my destructor also. Base, the name of the class, because destructors also do not have any written type. So I will start with the name of the class to which it belongs to, scope resolution operator, and the name of the destructor. So I will say cout endl in base class destructor. Let me close it here. So I have base class constructor and base class destructor. Fine. These are the two things, the base class constructor and the base class destructor. These are the statements, because since I have put a cout statement with a proper endl prior and after, so there will be a new line inserted beginning of this text and then after this. So this is what I have written in my base class constructor. Fine. Please make a note of it. Now let me derive a class, that is class derived colon visibility mode is public and then base. Okay, let me write in the public section the derived class constructor and the destructor. See, the thing is, constructor and destructor do not get inherited, but they are invoked in a sequence in inheritance. So we will see when I run this what sequence does it, what is the order of execution of the constructor and the destructor. So in the public section of the derived class I will say derived, and then I will say tilde derived and close it, close my. So this is the default constructor of the derived class. Of the derived class and this is the destructor of the derived class. There is nothing like default because destructor is only one. So since it does not take any arguments, you cannot overload it, whereas the constructors can be overloaded. Such constructors which takes parameters are called parameterized constructors, and the constructor which do not take any arguments is called a default constructor. So destructor, there is only one destructor per class. So I can say derived class destructor. So please have a look, then we can write both the constructor and the destructor. Then I will write my main and the output, which will show you the order of execution of constructors and destructors in inheritance. So now let me write the constructor. So the name of the class to which it belongs to is derived, scope resolution operator, function is derived, and I am writing the constructor here, cout endl in the derived class constructor class constructor. Yeah, since it's a function, I am not putting a semicolon there. I am writing cout in the derived class constructor for the constructor. Same way for the destructor, derived cout endl in the derived class destructor. So I am saying in the derived class constructor and in the derived class destructor. This is what is printed. In the base class also I have written in the base class constructor, in the base class destructor. And through single inheritance I am deriving a class derived from the base class, that is from the class base. Fine. So this is the derived class constructor and destructor. After that I do have to write my main. So void main. How will I execute it? To execute a default one, whenever you need to create an object, the default constructor is run. So what is the default? Which class will I be creating an object? I would be creating an object for class derived, because B also, like derived would have derived would have got the properties of the base through inheritance. So I'll say derived D obj. When I say derived D obj, automatically it will allocate memory for the elements of the derived class, and then in turn the base class also, because derived class would have the copies of the base class. Then I will say get ch and close it. So now tell me what happens here. When you create an object of the class, the default constructor is run. Then I am creating it when I am creating it to the derived class. So what happens? The output would be, first the base class constructor would be run and then the derived class constructor would be run. So what have I written? How will I know? Because it will print me in the base class constructor. Then it will say in the So first it will run whenever, if there are 10 classes also, first it will run the first base class, the second, the third, the fourth, like that. So first it will say in the base class constructor and then in the derived class constructor. Then in the base class so next it will start for destructors. First it will deallocate the last derived class, then the next, like that. For base class it will allocate memory for the base, then the derived 1, derived 2, derived 3, like that. Whereas for the destructors it will deallocate from the derived to the base. So it will say derived class destructor first and then the base class destructor. So this is the order of execution. Constructor from base to derived classes, whereas a destructor from the last derived to the base class. This is how it works. For example, I have these 3 classes. If it is a constructor, it will work this way. It's a destructor, it will work this way. Please have a look. Hopefully you have understood this chapter, and this would complete our inheritance chapter. So we completed with the chapter 10, that is inheritance, and we will be starting with the chapter 11, pointers. So this is the weightage of this chapter is 4 marks. So you will get 1 1-mark question and 1 3-mark question from this chapter. Like you will get a 3-marker from this chapter and 1 1-marker. Like if you are aiming for 100 out of out, like 70 on 70, then you need to be very good in this chapter. You would get a 1 marker, and 1 marker does not have choice in the final examination. So in order to get centum, you need to write all the 1 markers correct, and you get a 1 marker from this chapter. So if your aim is to get full, you need to pay attention for this. So we'll be starting with chapter 11, that is pointers. So the objectives of this chapter. The objectives, like by the end of this chapter, we would be completing the declaration and the initialization of a pointer, like how do we declare, how do we initialize, and then the characteristics or the advantages of pointers. Yes, it should be advantageous, otherwise we'll not be using it. So what are the advantages of pointers? Also we'll be doing then expressions and pointer arithmetic, memory size, and array of pointers. Like what is an array of pointers? Till now we have done array of integers like numbers, characters, strings, which is nothing but the array of characters, an array of objects. We have done an array of structures, so we'll be doing an array of pointers here. Then pointers with one-dimensional array, strings, structures, and objects. Like we'll be doing all this within programming example for each. And pointers and functions, this is very important if you plan to study computer science further also. Yeah, this is a very important concept. Call by value, call by reference, and call by address. And what is the difference between these three? Like how is it different? We'll be writing a program for each, and then we'll write all the 3 methods in one program, get an output, and we'll compare the output so that you can know the difference. After that, use of this pointer, again this pointer, many 1 markers come from this, and static and dynamic memory allocation. Like what is static? Till now we have done any memory allocation during the compile time is static memory allocation. We have done that. Now we'll be doing dynamic memory allocation, like during runtime. If you're allocating memory, that is called dynamic memory allocation, and new and delete are used for dynamic memory allocation. So how do we use it? What is new? What is delete? Where is it used? All of this we would be doing in this chapter. Please have a look at the objectives. Next is pointers. So what are pointers? Like why do we need it? It's a concept in C++ which has the following advantages. It is like we can write efficient programs using efficient and powerful programs using pointers. Memory is utilized properly because you can allocate and deallocate memory or make during runtime using pointers, and dynamically allocate and deallocate. Like allocating is fine, but then when you're not using it, you can deallocate so that that memory can be utilized by some other element. So it is the proper or efficient memory utilization. So when you have proper memory utilization, you will not be wasting it, and then you will be directly accessing the address. Your programs will be more efficient and faster. Please have a look at it. The next is memory utilization. So memory is organized in an array of bytes, see something like this, and each location in memory would be an hexadecimal number. Okay, and memory address, each location in memory, it's normally an array of bytes. So what is a byte? Byte is nothing but 8 bits. So 8 bits is equal to 1 byte. And what is a bit? 0 or 1 is a bit, that is 0 or 1 is a bit. and then 8 bits are 1 byte. It's an array of byte. Yeah, memory is nothing but an array of bytes, and each location has an address associated with it, and it would be an hexadecimal number. That is, hexadecimal is 0x and the number. So the number, hex number, can have from 0 to 9 and A to F symbols, and an hexadecimal is 0x. It's preceded by 0x and then the number, which means that 0x nothing but it's an hex number. And memory will always be an integer. It will never be a float value. It will always be an integer value. It's always a commonly asked question in the exam. Like memory address is an integer, as well as the array subscript also they will ask. Again, it is an integer. So it will be an integer, which is a hexadecimal integer. Address is nothing but an hex number, and it's an organized array of bytes, and each byte has a unique number. This number is nothing but a hex number. Here I have this. So this is a unique number which is called the address of that location. This is very important, address of this location. Variables are declared before they are used in a program. Yeah, in C++, you need to declare a variable and then use it. If you are trying to use a variable before declaring it, it will give you error. Like for example, I'll say cout x, and in the next line I'll say int x. So it will give you error, like because you have not declared x but you are trying to print it. So a variable not declared, error definitely you will get. So whenever you want to use a variable, you need to declare it. So declaration of a variable tells the compiler what happens when you declare a variable. Like if I say int x, for example, I am declaring that I am going to have a variable x which is going to store an integer value, right? It's a variable because I am not giving it's not constant, right? Because variable can change its value throughout the execution. Like initial value I can say 0, I can go on increasing, decreasing. It can have any kind of value and it need not be constant. Whereas a constant, again const if I use, it will have a constant value which does not change during the execution of a program. So when I say int x, what happens? This is the declaration of a variable, right? Int x is nothing but I am declaring a variable x of type integer. That is the value, that is the variable x is going to hold an integer value. Declaration of a variable tells the compiler to perform the following. Allocate a location in the memory. Yeah, you need to allocate a location in the memory for x, and the number of location depends on the data type. Yes, number of bytes depends on the data type. For example, if I say int x, it will allocate me 2 bytes of memory. And then you establish a relation between the address location and the name of the variable. Yes, when I say cout x, for example, int x is equal to 10, cout x, then it should print me 10. So first what it will do, when I say int x, then it will first, depending on the data type, integer, it will allocate 2 bytes of memory to me. Here it can be, for example, it allocates 2 bytes, then x should be associated with this, and then I store a number here 10. So whenever I say cout x, it will come here, retrieve whatever is the value present in that location. So number of bytes allocate memory, and then the number of bytes allocated depends on the data type. And then you need to establish a relation between the address, that is the location, as well as the name. So whenever you refer to this name, it should be able to retrieve data from that location. And if there is no relation, it will not be able to know from where to retrieve. So there should be a relation between the variable name and the location allocated, that is the memory location allocated to it, so that if you are storing and retrieving, it should happen from that location only whenever you refer to that variable. Hope you are clear with this concept. Please have a look and go through this. Now the continuation of this. For example, int num is equal to 15. So what is this? This is declaration and initialization of a variable. So I am declaring an integer variable num and giving an initial value 15 to it. This is called declaration and initialization in one step. In two steps, how will it happen? In two steps is int num. In one step, num is equal to 15 in another. So this is the two-step one. This is one step. That is declaring it and giving an initial value to it. Int num is equal to 15. The declaration tells the compiler to reserve a memory. Okay, location in memory, yes. So for example, these two are the memory, because since it's an integer, I would need 2 bytes of memory. Each byte is having one memory location. The address, yes. And each byte will have a unique address associated with it. So since it's an integer, it will have 2 bytes. So num would be having 2 bytes, that is 100 and 101 are the 2 bytes of memory which is allocated for integer num, and then I am storing in that location 15. Getting it? That is, the declaration tells the compiler to reserve a location in memory. We know that the size of the type is 2 bytes. So since it's an integer, it's 2 bytes. So depending on the data type, that many bytes of memory would be allocated, and the data, suppose if you give an initial value or you ask the user to enter whatever, whenever the value is entered, it would be stored here, and when you want to retrieve it, you can retrieve from this location. That is why it will form a link between, it will create a relation or a link between the name and the memory location. This is how memory is utilized. Next, what is a pointer and what is an advantages? What is a pointer? A pointer is a variable that holds a memory address of another variable. So it holds a memory address. How is it different than a variable? See, a variable holds a value with it. A variable holds a value with it. For example, if I say int x, x is equal to 10. What am I holding? A value with it. Whereas a pointer will hold a memory location, which would be a memory address. Okay, a pointer variable is a variable that holds a memory address of another variable. A normal variable holds a value, whereas a pointer holds the memory location of another variable. That is how it is different. So a pointer is a variable that holds a memory address of another variable. The advantages of pointers can be a 3-marker question. So the advantages, each would be half mark. So you will be writing all the 6 advantages if you want the 3 marks. The advantages are: pointers save memory space. Yes. How does it save? Because you can allocate and deallocate memory during runtime. During runtime, like I am allocating 10 bytes of memory using a pointer, then after some time when I don't need it, I can deallocate it so that it can be reutilized. That is how it saves memory. Then it is easy to deal with hardware components. It establishes the communication between the program and data. It is used for file handling. Yeah, when we do files, we will learn how the pointers are used for file handling. File, what are the different things associated with a file? The reading, opening of a file, the reading of a file, opening of a file in read mode, write mode, append mode, and then closing a file. So all these are different operations which can be performed on a file. So how are pointers used for file handling? And it is used to create complex data structures. Like after pointers and files, we will be starting with data structures. So how do we need pointer to create data structures such as linked list, stack, and queues, trees, and graphs? All these are different data structures. How do we use to create this complex data structures using pointers? We'll be learning that, but then pointers are used for that. That is one of the advantage. So advantages are this: memory space, allocation and deallocation during runtime, communication between program and data. It is used for creating complex data structures, and it is used for effective file handling. So these are the advantages of pointers. Please have a look, go through this. Now we'll do the pointer declaration. So how do I declare a pointer? This is the general syntax of declaring a pointer. That is the data type, yes. So for example, if I say int, integer, star, yes, without star, it becomes a normal variable. With star, it's a pointer variable. Okay, star is compulsory. Star indicates that it is a pointer variable, and then the name of the variable, I can say ptr. Again, it is not compulsory that it has to be ptr only. You can give any identifier name and you need to follow all the rules applicable while naming a variable. So this is what we are going to do. Int star ptr is nothing but a pointer which is going to point to a memory location having an integer value. The same way, initialization and declaration of a pointer. See, when I say int x is equal to 10, what does it mean? I am going to declare an integer variable x and it is going to the initial value is 10. This is a normal variable. So, the same way, how do you give an initial value, declare and initialize a pointer? So, I have to say int star ptr is equal to ampersand x. Fine. This is how I declare and initialize. Why is this? So, what happens if I say int star ptr is equal to x? This will give me an error. And this will not give me an error. Why is it? What does the ampersand do? So, we'll learn this. Now, I'll write and show you how does it matter, like why ampersand is compulsory and why is this wrong. Fine. So, you please go through this, then I will write it. I'll explain you why it is allowed, why is it not allowed, what is allowed with a pointer and what is not allowed with a pointer. So, see, if I say int x is equal to 10, what happens? Like we did that memory allocation. For example, each one is a byte of memory, and then I will say the memory location is 0x, this one too, it goes on, it has something. Then if I say int x, x would be here, 2 bytes of memory would be, each block is 1 byte of memory, 2 blocks would be allocated and then 10 would be stored here. Fine. This is what it happens. Then if I say int star ptr is equal to ampersand x. Why is it ampersand? What does the ampersand do? See, pointer always points to a memory location. So, when I say memory, ampersand gives the memory location of x. So, suppose ptr is created here in this location, then it would point to this memory location. So, whenever I say I cannot give a value to a pointer directly because I cannot force the compile, like it is associated with memory, so I cannot force that it has to be this memory location only. It is always system specific. Getting it? So, I can say point to this memory location wherever it has been created. I cannot even say this. It will not allow me even this. If I give the memory location of x also, this also is wrong. It will not take. I need to give the address of something only so that it will point to that. I cannot assign it to a value. Pointers, you cannot enforce that it has to be created here only and this has to point here only. You can, that is why whenever I am assigning it or making it point, I have to use the ampersand, which will give me the memory location of the variable to which it is pointing to. Hope you have understood. I can't do this also. Int star ptr is equal to ampersand x and then int x. This is not allowed because x should be there first, then only I can make it point. That is also very important. From this, what we have established is I cannot give a number to it. It always has to be a this one only, address only, and address I cannot write it this way. It has to be ampersand and some variable. So ampersand x will make the pointer point to the memory location of x. This is not allowed. Please make a note of it. Now we will go through, write a program to display the value and address of a variable. So we'll do these two programs. By the end of it, you will have a clarity about how pointers are used and how like normal variables are used and how we can get the same values using a pointer. Getting it? So write a program to display the value and address of a variable. So I'm not having a pointer here. Without a pointer, I'm going to create a variable. I'm going to give an initial value to it, and then I'm going to print the value of that as well as the address of that variable. Clear? So we'll start with the program, the first one. So how do I do that? Hash include iostream dot h hash include conio dot h. So let me make it a standalone program. So how do I do that? I'll say void print. Okay, let it be a void print. I will say int x is equal to 50, or you can take it from the user also. So let me give an initial value to it as 50, and then what will I do? Cout value of x. Fine. Cout value of x, what will it do? It will print me the value of x, that is 50 here. Cout. Whenever I say address, it is definitely the memory location, okay, memory address, which is a hex number, address of x. I'm not using pointer anywhere here because you don't see declaration with a star. X is a normal variable. So how do I get that? Ampersand x, okay. Ampersand x would give you the address of x, and only x will give you the value of x. And after that, just close my print function. Then I will write my main, void main, then clr scr clear screen. I need to call this function, otherwise without calling the function it will not execute. Print print, open and close brackets, and then get ch. This is the end of my program. I'll execute it. What is this? This is the function call. See, without calling the function, it will not execute. What am I doing here? I am having void print as my function. Int x is equal to 50. I am having a variable x, and I am storing the value to 50. Cout value of x would be printed as it is, and then after that x is printed. Okay. After cout the address of x, so ampersand x. When I say ampersand x, the address of x gets printed because of this ampersand. And then void main, this is what I am doing in the program, that is I need to print the value and address of a variable. Void main clear screen print, I am calling this print function. So it gets executed and get ch. This is the end of my program, and the output would be 50, that is it will print me the value of x 50 and then the address of x, some hexadecimal value which is the address of that variable wherever it is created in the memory. Hopefully you have understood this. Please have a look. Now we'll do the second program. What is that? Write a program to assign an integer number to a num variable. So the name of the variable is num and it is a type of integer. The data type of num is integer and it is a variable. Assign address of the num to a integer pointer. So you need to create an integer pointer and make it point to variable num. Okay. Display the content of num. Content means the value of num and the address and the value of the variable num using a pointer. So you need to display the content of num by using the variable num. Also you need to display the value and the address of the variable num using the pointer. So getting it, like I need to declare an integer variable and I need to assign a value to it, and then I need to declare an integer pointer, make it point to the integer variable, and using the variable display the value of it, and also using the pointer display the value and the address of it. So these are the things I need to do. So we'll write this program. Hope you're clear with the statement of the program. So hash include IO stream.h, hash include conio.h. So let it be a standalone. I'll write it as a standalone function, but then it can be a part of the class also. If you write it as a part of the class, you need to write it in public and then create an object and call it. Let me write it as a standalone function. So void pointer, pointer operation. So I am doing pointer operations. Let it be the pointer operation. Okay. Then int num is equal to 20. So the first thing is initialization and declaration of a variable num. I am declaring a variable num and I am storing the value 20 in that. Hope you are clear with this. Now int star ptr. So I am creating a variable ptr of the type pointer. It's a pointer because I am having star ptr here, and equal to ampersand num. So it is going to point to num. Fine. And it is there. So it will so it will not give me any error here. What I am doing here, I am declaring a variable num of the type integer and storing value 20 here, and then I am creating a integer pointer and ptr, and then I am making it point to num. That is why it is ampersand num, because pointer always points to a address of a memory location. So ampersand num will give me the address of num. So ptr is pointing to num. After this, I need to print the value of the variable num using the variable. So how would I do that? Cout endl num is equal to, okay, I will be writing num here. So what it will do? It will say num is equal to and num. The value of num is 20, so it will print me 20 here. After that, I need to print the value of num using the pointer also. So let me say endl value of num using pointer variable. So how do I do that? The value of num using pointer is star ptr. So when I say star ptr, when I use star, it will print me the value which is present in the location to which it is pointing to. So star ptr will give me 20. That is, since ptr is pointing to the location of num and the value of num is 20. So star ptr will give me the value to which value present in the location or the memory address to which it is pointing to. Next is cout endl address of num using pointer is just ptr. So when I just say ptr, it will give me the address, memory address would be printed here, and when I say star ptr, the value which is present in that location would be printed. Please make a note of this. Star ptr will give me the output would be num is equal to 20. Second one, the value of num using pointer will give me 20. The next one will give me 0x, some memory location. It will give me a hexadecimal number because only ptr will give me the memory location to which it is pointing to. So ptr is pointing to num here. That is why it will give me the memory location of num. Whereas star ptr will give you the value which is present in the address to which it is pointing to. So this is how you write it. Then you need to write your main function and call it. So void main clear screen, then pointer operation get ch will complete my program, which is nothing but this is the function call. I am calling the function and you are writing the once the function is called, it will go back and it will execute the function. And in the function, what are the things we are doing? We are like creating a variable, we are creating a pointer, and we are making the pointer point to the variable. We are printing the value of the pointer using, we are printing the value present in that location to which the pointer is pointing to, as well as the address of the pointer using address of the variable using the pointer, and then the value of the variable using the variable. So these are the things which we did. Next class will continue with this. Hope you have understood. So please make a note of it and please make a note of today's homework questions. Homework. First one, what is virtual base class give an example. So what is virtual base class? And give an example. The next one is, how does inheritance influence the working of constructors and destructors? So please make a note of it. Hopefully you have understood pointers, and then we'll continue with that chapter. Take care, stay safe, see you tomorrow. Bye-bye.